Craig, I don't know how I tricked you into coming onto the show, but yes. Thank you very much for doing that. Here's why I know you're a rock star. I could never wear a cool sweater like that.
Oh, I'm sure you could.
I couldn't. If I did, they'd just look like the world's largest beanbag chair walking across the lobby. Nobody would ever give me the time of day. Thanks for coming on the show.
My pleasure.
Before we get started, could you introduce yourself and
Sure.
a little bit of your background in our industry?
Yes. So my name's Craig Pennington. I have been working in this industry for 25 years since I left the Air Force, Royal Air Force, not USAF. Mm-hmm. Initially, I was working for a company called PSINet. They were a .com darling, .com bust. Went off then to work for NTT for many years, 10 years or so. Then to Equinix. At Equinix, I started off doing sort of major investigations for large-scale failures in Europe. One of the things I always remember is Eric Schwartz said, "Hey, Craig, you know when you were at NTT, you were always complaining about this particular site?" I said, "Yes, Eric." He said, "Go fix it." So that was a nice introduction. That was my first day at Equinix. And then 11 years later, having sort of moved from the UK to the US and taken on global design responsibility for Equinix, Oracle sort of came along and said, "Hey, would you be interested in helping us grow our capabilities?" And so that was 3 years ago. And so in that 3 years, we've gone from taking down relatively small amounts of space in co-location companies, 2 megawatts at a time, to now building out gigawatt campuses. And so that my team has been right at the heart of that, because my team does all of the engineering reviews of either the colos or the developers to make sure we're getting the product we need. And obviously the world has changed just dramatically over the past 18 months, 24 months with just the advent of the AI GPU engines that are now coming along and sort of bifurcating the industry on the need, standard compute, and then this GPU behemoth, which is driving so much global capacity.
Yeah. When you first started, how long ago did you come to the States, relocate here?
I've been here now, 12 years. Is that right? 12 years.
12 years.
Yeah.
Do you miss being back in the UK?
Both sides of the Atlantic have changed dramatically.
Yeah.
And so the UK is not the UK I left. I mean, I still have an apartment there. I still go back and visit friends, but I don't miss it. I'm older.
Yeah.
London would have killed me just from the amount of things you can do there, partying and drinking and eating. I'd have been dead by now. So moving to California, all of the trappings of a major city in San Francisco, but all of the ability to be out in the countryside and be on the beach with the dogs and be in on Mount Tam on the bicycle.
Right.
It's a different lifestyle, but one I definitely have grown into. I love it here.
When you're describing that, it reminds me of I don't remember if it's a movie or a conversation with somebody, but it was from the 60s, talking about how much things have shifted. They were it was a New Yorker and a Londoner that had both ended up in LA. They ended up falling in love in LA and then moving back. I can't remember where, if it was to the UK or if it was to New York, but the California life was just too busy, too crazy, too out of control for them. And the irony as you described this, to me is, seasons change in locales.
Yeah. Well, it depends on where they are in California. I can imagine if they were in LA, frenetic and very London-like, but with a different slant.
Right.
San Francisco is a much more laid-back city, a lot more chill, and it is a lot more about the sort of healthy balance of work, social, and then health and recreation outside, and just driving down here today, it's glorious sunshine. It's the start of December.
Yeah.
That would never be possible in the UK. In fact, driving down here would have taken 4 hours, and driving around London, so it wouldn't have even been something I would want to try.
I don't know why so many Americans, I being one of them. I've never been to London. I'm so attracted to go. Next year will probably be my first year. London and Dublin, and yet I meet all these Irish and whatever people, and they're like,
No. No one should get it wrong. London is one of the world's great cities.
Sure.
No question. best sort of selection of restaurants, amazing theatre, access to anything you want to do in London.
Right.
But, it's just a different type of life, and I'm older now,
Yeah, I was about to say,
and I need
we're
to
not
slow
25
down.
anymore,
Yeah, exactly.
right? Our very, very, very good friends in the States are from Manchester.
Mm-hmm.
And a couple things one, they love the UK, but they don't want to move back.
Yep.
They're US citizens now. And they said, look, we'd love to go back and visit.
Mm-hmm.
I grew up, my grandparents my parents were the first graduates of Santa Clara High when it became Santa Clara High. So when I was a kid, the first house I remember was in San Jose. And then my dad relocated us up to Boulder Creek. He worked at IBM for years. My grandfather was over at Moffett Field as an engineer. My other grandfather and uncles owned radiator shops all through the valley. I'm sure I don't know what the statute of limitations is for speeding up from all through Sunnyvale and San Carlos and Redwood City and all the way up to Menlo Park with deliveries. But I would come up many summers. We ended up moving away and then back to LA before I joined the Army and then started my career. But when I come back and visit, there's a lot that I love from my memories. But I love living out in Atlanta now. It just matches my pace of life. And I didn't really have, as a young adult, memories of the Bay Area, although I do remember when they put in Great America. Mine was more LA. Yeah. And so it was more that frenetic than San Francisco.
So I love visiting down there, but living, I live in a fantastic area. I live right in the marina. I live in Ira Gershwin's house.
Oh, wow.
So my living room is where Ira and George used to put together all of their music. And I use it predominantly for music. I'm a massive audiophile. I have valve amps and amazing speakers and so that's like my listening room.
Right.
And fantastic view out over the Palace of Fine Arts and so the difference mentally for me between London and San Francisco is, as my career has grown, my ability to sort of move into nicer places has grown.
Sure.
And so there's a bit of an imbalance. You can't compare what you can achieve, at 55,
right,
with what you can achieve at 30.
Right.
But I still have fantastic memories of London, and I will never decry it. It's an amazing city.
Well, what they talked about from Manchester was, look, they love to go to the city as well.
Yeah.
And I was talking to them about the GDP of the UK, and they said, but about 90% of it is in and around London.
Yes.
And the further north you go, the less it is. So they grew up very working class Manchester.
So I'm from Manchester.
Okay.
I mean, not originally. I was born in a place called Carlisle, which is the northernmost city in England. Okay. So if you can imagine, the one that's better known is Newcastle. Yeah. That's on the east side. Right. Carlisle is on the west side. Right. But then when I was 5, we moved south, and I grew up in a little place on the outskirts of Manchester called Bolton. Okay. And then it was sponsored through my university by the Air Force, the Royal Air Force. And they took me on as an engineering officer. I did 11 years with them, and then thought it's probably about time to leave and make some proper money. And that's when I sort of went into the city and started with PSINet. Right. And that was really fortunate. I mean, it's a bit of a longer story, but I went down to apply for a project manager's role, and I interviewed, and I was leaving the Air Force as a squadron leader. I was one of the youngest squadron leaders in the Air Force. I was 30 at that time. As an engineering officer. And I went down for this interview, and all credit to the person that was interviewing me, a gentleman called John Turley. Mm-hmm. He immediately after the interview went into his boss and said, I can't hire this guy. His skill set's too big for what I have available, but you should meet him because we should certainly hire him. Mm-hmm. And so I'm on the train back up to my house, and my phone rings. I had a mobile phone, weirdly. And they said, hey, Craig, can you get on the train and come back into London? We'd like to interview you for a project manager job for the European project director's role. I said, sure. So I went and crossed the platform, went back down. The European managing director at the time was an ex-RAF warrant officer. So I meet him, and he understands me. He gets my experience, which is so rare. Yes. Right. And I was very meticulous in not making everything jingoism and military speak, because it's really easy to fall into that pitfall when you're trying to present yourself as a vet. And I was very careful to sort of still make the full point. But he went, yeah, I'm ex-RAF warrant officer. I know exactly about you. Yeah, you've got the job. Don't worry about it. So that was my sort of leaving the military and joining the civilian workplace straight into this job. And it only lasted a year because it was one of those tumultuous sort of times when lots of companies went belly up. I joined in sort of November 99, just in time for everyone to lose their minds over whether the Millennium Bug was going to kill everybody and we're all going to, it was all over. Yeah. Only to find out it was a damp squib and nothing really happened. Right. And then, so worked there for just a year until it sort of all went horribly, horribly wrong. And I went off then and, a little stint there with a small startup, which again couldn't get funding, and then straight to work for Verio at the time, but Verio, an NTT company. NTT, very Japanese, takes time to absorb new companies before it allows you to use their name. So we started off as Verio, then Verio, an NTT communications company, and then NTT Communications. And by that time, it was me moving on to Equinix.
So they're like the Datsun of the Nissan world. We'll let you use another name for a while until
we've worked out whether you are worthy of using the NTT name.
That's right. How cool is? I love to hear stories like this where the universe conspires to just at the right time and just at the right circumstance.
Yeah.
And you recognized it. I'll bet you a lot of these intersections could happen to us, but we don't recognize them.
I make the assertion that I've never interviewed for a job in my life. Not really.
Right.
I mean, I did initially when I was sort of going through to get sponsorship from the Air Force, but that was to give me money to go to university. So I didn't really interview for a job at that point.
Right.
But at the end of that came a job.
Right.
And then after I decided to leave the Air Force, yes, I went to talk with these people, but the job I went for wasn't the job I got.
Right.
And then when I got bored with working for NTT, I was just having breakfast with a good friend of mine called Michael Winterson, who was running the UK at the time and is now off doing things with the European data center community. He said, "How are you getting on?" I said, "I'm getting to the end of my time, Michael. I'm bored." Well, come and have a chat with Eric, and we'll see whether we've got something for you. And sure enough, now it started working for Equinix. So,
wow.
But yeah, it's always been these. People engineer their own luck to a certain extent,
sure.
But you still got to have the luck.
Right.
If you're not in the right place when the right opportunity presents itself, you don't get the option.
Yeah.
And so you can be incredibly talented. I'm not saying that I am, but you can be and never make it because you just weren't in the right place at the right time. But I've been fortunate. My move to the US was precipitated because I was at an offsite. It was Equinix's. Engineering sort of operations senior leadership offsite. It was in St. Petersburg in Russia. Not going to do that again. And even then I was thinking I've got to be very careful about going because I'd been to the Ukraine before diving, and I'd been accused of being a spy in a Russian magazine because we were diving for the wrecks from the Crimea and being invited by the Ukrainian Navy, but the Russians still had all their nuclear subs around the corner in the pens in Sevastopol Harbor, and so we had a rather fraught standoff one day on the beach when there was a couple of Russian guys and the Ukrainian border patrol, and we were with the Ukrainian Navy. And they tried to arrest us, and the Ukrainian Navy said, no, that's not happening. We had to get the ambassador down from Kyiv to come and sort of smooth things over. So, even going to Russia was a bit of an issue for me. I was thinking, am I going to make it back out? I would definitely never go anymore.
Right.
And so I'm in one of the presentations. Ralph Abdel, who's now the chief operating officer for Equinix, says, hey, my head of design has resigned, and so I'm recruiting. And so I came out of the room and I said, I want that job. He said, okay, send me your CV tonight. Let's have breakfast tomorrow. Let's talk about it. And this was October 2013. 2013? Yes. And April 2014, my wife and I were on a plane to San Francisco. We've been living there ever since.
And who knew all those years ago that the skills you learned in that Ukrainian standoff you could use in Santa Cruz if the local surfers get irritated that you're trying to surf in their territory.
Yeah, absolutely.
You could just. What does your wife think? Is she as enthusiastic as you, or is she more?
No, so it could have gone really badly wrong because every time we'd been to San Francisco up until this point, we'd stayed in nice hotels, the Four Seasons. They used to have a Four Seasons downtown. But at night, if you come out of the Four Seasons and turn the wrong direction, you're in the Tenderloin.
Right.
And so, and also even if you don't turn the right direction, the business district at night is dead.
Right.
And so our initial perception of San Francisco was not the best.
Right.
Because we'd had that, we'd seen the Tenderloin, we'd seen sort of like nothing to do down there at night. When we went to then look at some of the touristy things, we ended up at the ferry building. And so, yeah, that's okay, but is this it? And so my wife didn't have a very good impression of San Francisco. And then I came back from St. Petersburg, having not discussed this with her, and said, hey, I've got some news. We might be moving to San Francisco. And that could have gone one of two ways. It could have been over my dead body or, sure, let's give it a go. And she just said, okay, let's do it. Because my wife's an artist. She's very, fun-loving. She likes to sort of try new challenges.
Right.
She's South African. So by the time we die, she may very well have had 3 different passports.
Wow.
South African passport, UK passport, US passport.
Wow. How'd you meet her, out of curiosity?
I tried to kill her in a bar in London. It's true, right?
None of this is on my question list, but it's way more fascinating.
It's so true. We used to frequent a bar. It was called the Bang Bar. It was in St. Catherine's Dock in an old, I would say, Elizabethan building, so old and rickety.
Right.
And the bar was up the first flight of stairs. And as you came up the stairs, you had to turn hard right, 90 degrees into the bar. And if you went straight forward, you ended up in the gents' lavatories.
Okay.
So what happened one day is I'm coming out of the lavatories, talking to a friend behind me. My wife, Inez, is coming out of the bar, and I'm not paying attention, and I'm a big unit.
Right.
And I hit her, not...
Right, I know what you mean, broadside her.
Yeah, broadsided her. And as she's about to fall down the stairs, I grab her and pull her close and save her life, having tried to kill her in the first place. Right. And we just sort of hit it off from there, and I found out she was an artist. I asked her to send me some of her work. She sent me some. I said, well, that's very much like Jack Vetriano. That's very much like Tamara Delempica. She went, oh, you know what you're talking about. And then I bought a piece off her because I knew how to navigate this. And we've been together ever since.
I'm going to put this together, right? So former Air Force, let's just say Air Force employee, who was under invitation to dive in the Ukraine, and the Ukrainian ambassador had to intervene because there might have been more than just diving involved. You end up back at this facility having absolutely no idea who that beautifully attractive woman there was. You just happened to be completely aligned artistically and kinetic spirit, and you just ram her and catch her from falling down the steps. And this is completely random. You didn't have a dossier on her.
Nope.
You didn't. I'm sure you've perfected that story, but I have a feeling you probably did a stakeout. You knew who it was, and you timed it just perfectly. What was the payoff to your friend to make him go with your story so that your wife thinks this is random? I think that's a well executed plan, actually.
It went pretty well. He got his champagne paid for. So.
He's living in an apartment in London while you're out here.
Exactly.
Well, I hate to pivot because that's way more interesting. One last comment my friends would talk about from Manchester, and they said, look, we'd love to go to London, but the traffic. I'm like, well, it's, when we were in Atlanta or even here in the Bay Area, if I wanted to run up to wine country or, there are times a day you got to avoid. But other than that, you could do it okay. And they said, you have no idea what traffic has become like to the city, much less around the city.
Well, that is true. Getting in and out of the city is painful, no question. But the UK is very different to the US, which is it has a very functional public transportation system. Trains really do work.
Right.
Taxis get their own lanes in the centre of London, so taking a taxi, though not cheap, is probably a much better way to get around.
Right.
And then this is where our industry has helped with some of the innovations, because things like electric scooters what was called the Boris bike. The way I used to get around London, because I was younger and fitter, and I am a very keen cyclist, I used to use the Boris bike because it was by far and away the quickest form of transport in central London. Okay. My apartment was right by Tower Bridge. I still have that. And my offices were right in the city. And so you could get on a bus and you could get to work in 30 minutes going over Tower Bridge, like crawling.
Right.
You'd be quicker to walk, or you could get on a Boris bike and be there in 10 minutes.
Wow.
And home again in probably, almost less time because it was sort of downhill.
Right.
So those innovations, the ability to sort of have a centrally managed, pool of bicycles, scooters, whatever it might be, would never have happened if it wasn't for the services that our industry delivers. Right. Because it's the likes of the data center that allows that connectivity to keep track of inventory and know where these bikes are. And so, the evolution of what we as an industry have been able to provide, which people don't think about. We think about, what's that big building do? It's full of computers. What do they do? Well, they do everything. Every part of your life is connected nowadays. Yeah. So transportation, just after that, being able to hire a car, but not by going to Hertz or to Avis or someone like that. Just because they're parked in the street and you have an app, which means you can open it and get the key out of the glove box and drive it for the day, or for an hour if you need to go shopping. Right. So in my entire time in London, and I lived there for 12 years, I never owned a car because there was never any need, and if anything, it was just more of a pain in the butt than it was worth.
Yeah.
I went back for work just recently and wasn't paying attention, got a hire car, drove in and out of central London where my apartment was to all the data centers I was looking at out in Slough, got back to the US and ended up with a £300 UK bill because for 3 days I wasn't paying attention that I needed to pay the congestion charge. And so $100 for the first day, $100 for the second day, $100 for the third day, and the bill turns up and there's nothing you can do about it because you've missed the payment deadline. So you're just getting penalty payment. And that's the downside of, driving when public transport does work. So.
Yeah. Well, I'm jealous of the idea of the public transportation. We don't have it in Atlanta. But I just went and stayed with friends in Woodinville, which is just north of Redmond, Seattle. And I was complaining when I got back and saw my toll charges for the rental car, but it was nothing like what you just described. It was, a fraction of that.
Well, no, that's exactly the point. The toll charge was like $10.
Right.
But if you don't pay it, you get the penalty payment. And the British are really good with their penalty payments. My God, they will extract every pound of flesh. So it's literally because I hadn't paid it and the deadline had gone, because guess what? It takes ages for mail to come from the UK to the US. It's like, and obviously going via the Avis.
Right.
Or whoever it was I rented from. And so, by the time it turns up, it's like, oh, fuck it, just going to have to pay this, aren't I? I'm going to pivot because we'll be here all day. What's interesting about, to me, among many things, is when you were joining our industry, coming out of the Air Force and joining our industry, it was definitely a time of disruption. We've learned that in a lot of ways we were early. We weren't wrong. We're just early. And there's a lot going on now. So when you're over at Oracle, to your point of where we started with, I went from a cloud provider, among other things, who needs, relative to the other people in this space, modest amounts of data center space and power, and probably not at the cutting edge of data center solutions that will fit into a wide range of deployments, from modest to large data centers with modest ability to remove heat or whatever. Is pretty not terribly exotic, and it gave you a wide range. Yeah. And now you guys, and I've heard you speak many times about this, are in the thick, just like several other players, in the thick of this disruption. I don't know what else to call it, revolution, whatever it is, of we have paradigm shift, if you want to use a trite
there you
phrase.
Go, paradigm shift. I love it. I haven't used enough syllables today, so this is getting me towards my quota. But the paradigm shift, and I don't want to say it was simpler in the 90s, early 2000s. That's probably the wrong way to think about it. But today, there's so many things that seem to be in the paradigm. There is the size of the data centers. There, just a few years ago, it was how do we use air to do certain things?
Yeah.
Then it was we're going to get rid of raised floor, and we were designing to a certain way. And how can we engineer more and more simplicity into our design?
Yeah.
And now this is how are we moving towards sustainability goals that are published? We have them, our customers have them. We're all moving towards these things. And then I'm reluctant to use a much maligned and overused term of AI, but whatever artificial intelligence, machine learning, all these other impacts to our world are having, we are in a shift. It's a series of shifts.
Yeah.
And so how do you, as a leader at your organization, you show up in a staff meeting with your team to design a solution that's got to live in a facility that we don't think, at least in my company, this facility is only going to be here for 25 years. We think it's going to be here a couple hundred years. We may have to repurpose it a number of times. And up until like an hour ago, that was fine. And now we're trying to figure out, wow, are we even thinking about this right? And as complex, I'm using that in quotes, as a data center is, it's infinitesimal compared to the environment that you are standing up, operating, and then at some point decommissioning.
Yep. And upgrading.
While in production.
Yeah.
And the mission could change on you. My mission isn't going to change terribly in my world. Where do you start? So in the audio room?
Massive,
with your feet up?
Massive question. Because this is the issue now, which is, you go back to that, 90s, 2000s. The building, you could build it, and it would have a 20-year life cycle. Mm-hmm. And certainly you'd be replacing components in there, the UPSs, batteries, blah, blah, blah. But you're not radically upgrading it, not massively. You might get some better performing chillers, and you reduce your PUE a little bit, but you won't be massively re-engineering the electrical topology, per se. And we had a good 10, nearly 15 years where average densities per cabinet didn't change a great deal.
That's right.
IBM and AMD and everyone else at Ampere were busy trying to make sure that the chips didn't breach 200 watts and so could be air cooled, and just kept on doubling up on the performance, doing the Moore's law thing, just keeping going.
Right.
And NVIDIA came along and went, yeah, we don't want to do that. We want to make it so that we can get the most performant chips that we can out to the market for AI, for this very specialized computational thing that GPUs can do. And as a result, we have to now think about re-engineering the data center at almost the same pace as the IT we put inside it. Yeah. Because we've got this bifurcation now in the requirements. You've got standard compute, which is now sort of, I won't say for everybody, but at least for us, is now in that 15 to 20 kilowatts per cabinet range. Yeah, so it's gone up, but it's not gone up dramatically. That's only a fourfold increase over nearly 20 years. Right. And then we've got this new thing, which has gone from H100, just under 10 kilowatts.
Tell people what H100 is.
Sorry, so NVIDIA's model numbers, let's call them.
Okay.
Yeah, so the first one that came to general market was called H100. Mm-hmm. And so we deployed those in a number of sites globally. Mm-hmm. And, just putting one of those into a cabinet, because we're going, hey, we can't massively increase the power needs, because that then causes problems with the busway and the amount of cabinets we can put in, and cooling. You end up with concentration if you end up with 20 or 30 kilowatts in a cabinet. So we spread them out, and so we made it so that each cabinet we deployed was around about 10 kilowatts, and that was just under 2 years ago, and then we've sort of gone straight from that to almost everyone wanting GB200, which is the current generation of the most performant chips that NVIDIA can ship. They're just starting to go GA now and be available for us to put into data centers. And you can see announcements from ourselves and from our competitors and friends and frenemies. And that's 130 kilowatts. So that's one cabinet, 130 kilowatts against one at 10 within 2 years. There's no infrastructure on the planet which is upgradable in that amount of time to deal with that disparity. And then, of course, you bring in the added complication of, oh, yes, and by the way, that cabinet has to be liquid cooled. And I think there's better ways to do the liquid cooling. That will undoubtedly come in the future, just because the densities are just going to keep going up. This is Pandora's box has been really opened, and so there's no putting this back in now and going, oh, well, we were fine. We'll just spread things out. We'll do it all air cooled. The key now is the closer everything can be together, the faster the networking can be. If you can keep it on copper rather than fiber, you reduce complexities. That means cram as much into a cabinet or its adjacent cabinets as possible. So this is an arms race now whereby it's just going to keep going up. We're at 130 kilowatts now. I think in 2 years' time, 0.5 megawatt, no problems at all. And people are already working on what does the 1 megawatt cabinet look like. So this is, it's fundamentally shifting. Well, what's the building and what's the distribution in the data hall? Because with the amperages and the voltages we're talking about and the delivery of liquid cooling direct to these individual cabinets, that clear distinction of the boundary of the white space and we hand over at the PDU, we hand over at the tap to the CDU. It's a hard one to sort of what's the demarcation between the building owner and provider and the IT. I think we've got it worked out, but our view of the world is a bit different to others. And how do you keep the building relevant as you sort of move forward? Just the deployment now. I mean, we have some massive sites, and they're going to be some of the most highly performant GPU installations in the world. And certainly, I think we'll take the initial crown for most concurrent GPUs in a single cluster. I think that's a given. But delivering that at the scale we're delivering it, we got buildings of these things that are 100 megawatt buildings. I've got 12-inch pipe work in the white space. That's insane.
Right.
We don't like water in data centers. We have spent most of our lives trying to keep it on the
cloud,
periphery.
Craig, we love water vapor.
Yeah, exactly. Yeah, the cloud. I like to keep it that way. Yeah.
Well, I didn't want to interrupt your stream of consciousness as you're talking to me, and I'm thinking about this as a, my company design, build, operate, and maintains data centers. That's what we do, and we try to stay really close to our mission.
Yeah.
And we spend time at the feet of customers like you and the other hyperscales, some of whom design, build, operate, and maintain their own.
Yeah.
But if they could keep up with it, they would just do their own, but they can't like everybody else. And so they engage us. And we get to sit at their feet all the time and work through these conversations.
Yeah.
And as you're describing this 20 years, this last 2 years of the 20 years, I'm thinking to myself, so what does the future role of a data center look like? Like whether it's how we engage to come up with design. Obviously, the chip manufacturer will also be drug in, and whatever the future chip manufacturers are. But what is the...
Well, that's the collaboration we can't avoid now.
Yeah.
The idea that you could build a data center and be pretty comfortable. It'll meet the requirements of 90% of your customer base.
Yeah.
But without having a conversation with the chip manufacturers and without having a conversation with the hardware manufacturers and those deploying it and the software vendors and then the end customers who are going to be driving these things, this has been my mantra for the past 2 years. Better collaboration in the industry drives for better outcomes for everybody, and problems are so complex and interrelated now. If we are not, encompassing everybody, including the utility companies, and we'll come to that in a second, we're all gonna build something which we think meets the need and will be wrong. Every one of us will be wrong because it won't either be able to evolve fast enough or it won't meet the underlying need. Some people got off to an early start and went for very high density facilities, and I think personally they've over-egged it. They've gone too dense, thinking, well, everything's going to be GB200. But yeah, sure, but it's got networking equipment. It's got non-GPU compute to do, to stand up the enclave, to be able to build the servers from the bootstrap servers, to have storage. All of that is your standard kit, but it's part of the solution. There's nowhere where it's just GB200s and just have at it 130 kilowatts per cabinet.
Right.
So you've got a very difficult design requirement now, which is, do you know how much of the installation for the customer is going to be air cooled or liquid cooled? If you don't know, how much of an overlap can you give yourself so that you've got flexibility? Because it used to be, if it's a 30 kilowatt room, and as long as you've got 30 kilowatts of cooling, sorry, let's say megawatts, my apologies, 30 megawatt room and 30 megawatts of cooling, and you've got +2 or +25% for resilience, that's all you needed to provide. But if you don't know whether it's getting extracted in the liquid or whether it's going out through the core units, the heat extraction, you've got to either be able to, you've either got to over provision and have an overlap, 85% liquid cooled, 50% air cooled. So you've got flexibility on the boundary, or you've at least got to have the positions available to be able to put that equipment in and have a supply chain that allows that to be possible really quickly. Because the one thing I can say from working at Oracle is you need to move quick.
Yeah.
The schedule, speed of delivery, is the number one priority, because what we're delivering now, I'm busy designing. I've designed things. We have data centers that are coming out of the ground now, and I'm already being told, yeah, but if it doesn't go live by the middle of it next year, we have to design for the next generation. So you're going to have to revisit it.
Right.
So everything that's out there at the moment for GB200 is great. We're going to GB300. So what is that now?
Right.
We haven't even got GB200s yet, so give us access to the data so we can start to make sure that our buildings are still going to meet the need.
The implication of that is I love it because you're just creating these pictures in my mind. This is my audio room, evidently, and it is before when we talked about power. Say it's a 30 megawatt, and I knew that if somebody was really efficient and on top of their design, and they could run that rack of 80% of its possible load, it might be a 10 or 12 kW rack. Most people didn't do that. They ran at 2 to 3 kW. Yeah. But I designed to that 10 and just figured I've got a lot of room. But here's what also goes into that when we talk about moving from air to liquid. So for example, in our original designs, we just had like a 30-foot ceiling, and now we drop the plenum way down. We create these plenums. We're on 4-foot raised floors in most cases. All these other things, capping, air handlers, and you could keep massaging out of this infrastructure. But those are relatively easy things, dropping things from a ceiling in a production environment. Like it's kind of like going into a nuclear, a small modular reactor on a Navy ship or at an Air Force base, and you're changing the cabinets or you're changing whatever. You're not really touching the reactor. When you start talking about the densities that we're talking about and the flexibility, the weight on that slab is much different.
Different thing, yeah.
And so do you over provision the slab?
I'm definitely advocating that.
And so, but what's, to your point though, what's the right weight? Is it 300 pounds per square, 500 pounds per square, 1,000 pounds per square? And then what is the impact to my sustainability goals? And here's where so this is one of the dilemmas, right? Yeah. The more I bring that liquid or other things in, it feels like the less room I'm going to have to do maintenance, the less room I'm going to have for people to move around. We were talking about getting raised floor. Now that's all coming back again. And now we'll just finish with this. I am sure at some point, you being the technology nerd that you are, when you had a computer in front of you or a nice plasma screen, one of the original ones,
Yep.
it weighed 1,000 pounds.
It
When
did.
the lights,
Yep.
when you turned it on, the lights dimmed or whatever. Now, if I had told you then, 15 years ago, that you could have a television that had quantum dots in it. It's
Yep.
going to be 8K. You can see the water molecule on the antenna of the fly. It would weigh 2 fingers. You could lift it up on the wall.
Yeah.
The wall. Why would we put our TV on the wall? Like all of these things. So it's exponentially lighter,
Yep.
but exponentially more powerful. Like how do you...
Oh, and by the way, it's a quarter of the price of the first one you bought.
A quarter, which gets me off onto e-waste and these other things, but at most a quarter with better performance, right?
Yes.
And so with all of that, if we had said back then, build an assembly line or build a home to support a 65-inch, 80-inch television and exponential amount of power and, all the commiserate relationship between power and weight and whatever,
Yep.
we'd have been really wrong. So when you sit there and you're having conversations, whether it's an operator like me or up in your channel, you got to fund this stuff.
Yeah.
You've got to design and operate it. You don't want it to collapse in on itself. How do you manage that conversation, the risk, how does this work in your world?
It's like the joke about how do porcupines mate carefully. So when you're trying to sort of get this into people's heads and explain to them, the complexity that this brings and what potentially could be, massive curtailment on the useful life of a data center, that 25 years without significant upgrades, it may not be 25 years. And so it is a really difficult thing so especially for me, my company is a software company. Its investors understand software SKUs, and what we're doing is radically different and sort of is a very capitally intensive set of work. And so it's a different mindset. And so getting people bought into why we have to spend this amount of money for the reliability, for the flexibility. I would say that Oracle has been probably at the forefront on recognizing the potential impact on the way these workloads run, what the implications of that could be for the electrical infrastructure, the mechanical infrastructure, the utility companies. We've been putting a lot of effort into that, but that is not reduction in complexity. That is additional complexity.
Yeah.
That is something that the industry has never had to deal with before. We've been at this a long time, Dave. And so, when we used to talk to the utility company, they only need to know one thing. How much power are you going to need, really?
Right.
Not what the building is, but really.
Right.
And what's the ramp rate to get to
That's
that?
right.
That's all they wanted.
That's right.
That's not the world now. The world now is, when will you need the power? Like from the moment we go live,
Right.
and what will it look like? It'll look like up, down, up, down, up, down, up, down, dramatically, not law of large numbers smoothing for diurnal variation. I mean, literally 100 megawatts, 30 megawatts, 100 megawatts, 30 megawatts forever. And that is profoundly different to anything we've designed for and delivered before.
Do you think that will be the case in all deployments? Let me ask it differently. So in a data center today, especially in a multi-tenant data center, I have a mix of loads. Now, nothing like what we're describing today, and I'm going to come to some of that in a second, but just over 20 years, we have hotter, colder, we do have some liquid deployments, and there's variation in the load. We've also gotten much better at what piece of this component actually needs redundancy.
Yeah.
Not everything fails elegantly. My storage infrastructure, maybe my fiber core, or whatever. But these other elements, you can turn them off, turn them on. It's not ideal, but it's not the end of the world. But I've got sort of like the grid. You've got all intermittent power, you got prime power, or firm power. I learned today, whatever it is, you got this mix of stuff, and we're pretty good at predicting the ebb and flow of what we need.
We were.
We were, fair enough, we were. And so I'm wondering if in a future data center, if you have some data centers designated as, I don't know if multi-tenant, but let's just call them enterprise, because some of what you're describing, at least in my mind, of these oscillating workloads are from big training environments or things
Bingo.
like that.
It's the training.
But if you're not only doing training, or because once you get to inference, like I'm taking it out. Sorry, I'm interrupting you. I'm getting you.
No. This is exactly what we need to be thinking about, because everyone at the moment is going massive clusters, huge data centers, huge clusters of data centers, because it's all about the learning.
Right.
The bigger the cluster, the faster it learns, the more data it can munge and make the decisions and get the model out of the end to be fed to the inference engines to be able to feed that to people who are asking questions.
And the inference engines I'm expecting, at least in the beginning, are going to be these small, like I will have an inference engine in a data center, maybe a few of them, but it's not going to be hundreds or thousands of megawatts of inference engines.
No, I don't believe so. And so this is one of the things that we as an industry have also got to sort of get our heads around, which is everything at the moment is about, huge amounts of power in locations where you can get it, and you have the land to build these data centers. And then what happens when the learning is done? And I'm not clear, and I'm personally not clear, do these learning engines go on to learn new things? Or do they then get cut into smaller proportions and become the inference engines? Now, I don't know the answer to that. And I think, the location of some of these make inferencing, sort of useful, but certainly not the initial place where you want to serve it, because you want that query and its response to be as close to the consumer as possible. So that sort of, goes to the data centers that, we've all been building over our past, careers, which are they're metro adjacent, and they're serving predominantly for that metro. And so those data centers, which we're currently looking at, it's sort of like it's 10 megawatts. That's lovely. How quaint.
Right. I have that in my ashtray.
Yeah, exactly. Yeah. So, but they'll have a resurgence. They'll need renovating.
Right.
They'll need access to liquid cooling. They will need to be able to carry the floor loadings, and they will need the power infrastructure to be significantly upgraded. But I think the inferencing is going to be sort of metro adjacent, and then the big learning engines will stay where they are and maybe go off to learn harder things and do other jobs. I might be wrong. I think there's a lot of money invested in these facilities, and once the learning is done, if that's however long that takes, maybe they do become like these 10 megawatt inferencing pods. But the advantage of that is that enormous sort of step load which comes from the learning is now sort of smoothed out to a certain extent by the fact that you've got 10 different inferencing engines where you used to have one learning engine, and as a result, you're not the partner that the utility would have an issue with. And so, it makes their lives easier because, they are used to, tens of megawatts going on the grid and coming off the grid. Everyone likes I would say a cup of coffee or,
Sure.
whatever they do in the middle of the Super Bowl. And, the world doesn't fall apart, at half time.
Right.
They can manage. But I just don't think they've ever done this.
They haven't had 400 or 500 megawatt data centers fluctuating like this.
Yeah.
So I wonder if they could solve. First of all, it sounds to me like.
But the technology all exists to fix this. This is not an intractable problem.
Right.
But it does require we as an industry, have a much more cohesive conversation with the utility companies about what's your base load capability, how big is the network in the location we're intending to deploy, how do you cope with dramatic swings in load. What do you have as far as StatCom on the network or spinning loads available to deliver power at short notice? What do you need us to do to make sure we stay within the frequency response characteristics of the grid in this location so that we don't overload it? No one wants, the utilities want to serve us power. They make money from that. That's good for them. but no one wants to be told that, the local town is having its lights flicker every 5 seconds because, we've introduced frequency instability. So we've got to work together to sort of get, and when I say together as well, this is, again, I keep on coming back to this. This is an industry-wide problem. If I fix it for me, but leave Microsoft and AWS and Google and everyone else out in the cold, or they go and fix it themselves but do it differently, well, we've got to. Number one is we'll get a bad reputation from the utility companies as an industry, and when we could have done it all the same way and been a good partner. Right. And number two is I think there's just so much risk there. We're trying to deliver new services and new products to the end customer, and fine, we're all competing, but we're competing for a pie that is growing so quickly. There's plenty of it to go around,
right?
And so I don't feel. There's certainly things which are proprietary, but that's in the software, in the infrastructure. None of this is secret. We all know how a data center is put together. We all now know what the problems are we're trying to solve for. So why are we not trying to solve it together? And so that's what I advocate for. At OCP, I was in a couple of sessions where we were looking at this.
Tell people what the OCP is.
That's the Open Compute project. And so that's been around now for 10 years? Yeah. And it's trying to give open source capability to say, hey, this is our thoughts about how best to design a data center and to design the equipment that goes in those data centers to be as efficient as possible, as responsive as possible, etc. And so with that sort of collaboration mindset, we started a couple of committees around what does liquid cooling look like, and how do we deliver it, and what does the control mechanism look like between the infrastructure and the building, so that we're not all telling the colos or all of our partners to do things differently. Because guess what? That means then, how do you build a building that's ready to go, not knowing what you need to expose from the control mechanisms, if Oracle and Microsoft and AWS and Google are all asking for different things? Let's get we may very well have, we definitely need this thing that Microsoft doesn't, Google doesn't want, or they need this, but there should be a core. This is not rocket. It's not rocket science. It's the thing that makes rocket science possible nowadays. Right. Yeah, but it's literally there's a baseline amount of information which we all need in order to make sure that the AI engines run, that they shut down should they need to because of a failure, because of a leak, because of whatever. If we have a baseline of data and it's all getting exposed from the EMS or the BMS systems in the data center to us in the same way, we've saved everyone a lot of money because we've got a standard.
Right. I'm curious. I don't even know where these started. I started in IT at the University of Texas. Accidentally ended up doing that. Story for another day. And then after 8 years there, ended up through a circuitous route in data centers. And so when I showed up, even at UT, and I would buy systems for my department, I had a standardized rack. So my compute requirements, I would go to a Dell in that case, and I would tell them what I want, and they would build a compute performance spec for me, but it fit in a standard rack following standard use. Yeah, they could tell me the not only how much data, depending upon the data I could crunch, but how much heat it was going to generate, what my power was. I didn't find any of those things. I just said, I want this stuff. So somebody had decided what a rack standard was, what a U standard was. Yes. And everybody that built, whether you were a Dell or an HP or whatever, because I want to be able to, as a data center provider, I want to be able to build a framework that I can put components in so that your electrons are working as fast as possible, as soon as possible. So, but I don't know that Dell, I don't know who came together that said, this is what the infrastructure or the framework looks like. Now you guys, customers, end users, For operators like us, we're going to build out the skeleton. You order from NVIDIA, maybe it's the NVIDIAs, I don't know. You order from the chip manufacturers, the chassis or the whatever, not just the GPUs, but that infrastructure. I mean, I'm wondering what the Vertiv's role and the Schneider's role and the NVIDIA's role and the big hyperscalers that we talked about and the data center operators that want to put the skin around it so that we know how to receive the infrastructure, get it deployed, your electrons start working for you. You can move around it safely.
Yeah.
We're responsible for the skin of the Death Star. You make the things within it.
Yeah.
Where does that... We've talked a lot about this, but how do we actually gain momentum?
Well, the demarcation was very straightforward for quite some time. The building delivered the cooling because it was CRAW units or it was a cooling array, and it delivered, in most cases, at least at the hyperscale side, not for retail, but it delivered to the PDU. And from that point on, that was the demarcation. It was into the room, and so that was the difference between the Death Star and the applications within the Death Star. And that's getting tested now because of the likes of NVIDIA being this gigantic new entrant to this space.
Sure.
We had for a very long time, just like we spoke about, cabs didn't really change from like 5 kilowatts ago. Well, guess what? They were 600 mil wide, and they were a meter deep, maybe 900 initially, and they were 42U high. Well, how did they keep on getting more performance? Well, guess what? Those cabs started to get a little bit deeper, didn't they? Because they went from like a meter to 1.1 meter to 1.2 meters. And then, all of that network cabling, well, 600 mils not quite wide enough. So how about an 800 mil wide cabinet, yeah? But at least that was the two variants. And then, fine, now we need to get even more in. But data centers can be quite tall. So how about a 48U or a 52U or a 58U now? And so there was always this standards are great. That's why there are so many of them, yeah? And so, you do your best to try and standardize, but at some point, things are going to have to change. There is no way the power we need in the cabinets that are coming can be delivered. I mean, the cable sizes now are getting insane.
Right.
As I said to you, we've got 12-inch pipe work inside the white space.
Right.
This has not been normal.
Yeah.
And that's overhead as well.
Right.
Because from a raised floor, and we can discuss the relative pros and cons of raised floor for what it now needs to do, which was the intention of separating out the water pipe work from all of the electronics above. But the problem is, then you have to have multiple designs because you might not be able to do that in a seismic zone. You might not be able to do that in certain buildings. I don't know what multi-story AI buildings look like. It's all of our work so far has been at relatively low level. And so, because these cabinets are getting super, super heavy, well over 3,000 pounds a cabinet. I'm sorry, I keep on going backwards and forwards between imperial and metric.
Yeah.
And it's because I only think in one thing, and then I hear words which have come up recently, and they're all American.
Look, you learned in the archaic way. You came to the States. You're learning it's
archaic.
You just celebrated Treason Day here.
Yeah.
Well, look, so as it relates to multiple story, we'll see. When we converted a few chip fabs in our time, and those were 2 or 3 story, and the weight in that infrastructure was so heavy. They weren't necessarily dealing with high heat, although they had high airflow, but nothing could move. It had to be ultimately stable. So they solved it. But do we really want to?
Well, they solved it for fabs.
Sure.
And when I've done brownfield in the past, and it's been a printing press or a smelting works.
Sure. Yep.
Well, sure, those slab floors, they will take this.
Right.
Converting an office building or making a data center as part of Tokyo, on the 50th floor and up,
It's not going to happen.
I just don't see how that works.
And a lot of most of the airflow, at least raised floor that I was around, it was just so that you could have a cold air plenum.
Yeah.
and then a hot air plenum above. Sometimes you use it to get your low volt, or you'd put low voltage above.
But
And
let's
high
be
voltage
self-reflective and go back
Yeah.
20 years. They were over-engineered. Nothing was ever pushing the envelope. So we, if it was a 10 megawatt room, and
Right.
it never was. It was a 2 megawatt room
Right.
because
Right.
let's be realistic for the time. We're not going to pulling more than a megawatt, maybe 1.2 megawatts.
Yeah.
So we're literally down at 60% utilization. So what did that allow us to do? It allowed us to get away with a lot of things you cannot get away with nowadays.
Right.
We've got a plenum. How about we run all the network cables underneath the floor? It'll be really neat.
Right.
And then over time, what do you find? That the plenum is now full of cables, and that cabling is now, impacting the airflow, and
right.
we're not getting the cooling. But guess what, guys? We've got plenty of it, because if we design it for 2 megawatts, and we're only doing 1.2. Nowadays,
can't
if
do
you
that.
give me 10 megawatts, I'm going to take 9.9, and
Right.
maybe if I can really make it work, I'm going to do 10.1, 10.2.
Right.
Because I know the UPSs aren't going to, fail at 10% overage.
Right.
And sometimes I'm going to
All
need...
the engineers are cringing right now.
Hey, I'm giving... Hey, I'm an engineer.
80% of that circuit rating, sir.
No,
80%
100%
of the
rated
rating.
breakers. That's the end of it. It's about time the US caught up to the rest of the world.
So when I think about racks and standardization, that data centers inherited it.
Yeah.
We really inherited it from the telecom business.
Yeah.
And the telecom business, once upon a time, was British Telecom
Sure.
or Ma Bell.
AT&T.
There was one, AT&T. There was one or two. And their engineers and their skunk works came together and said, this is how we're going to do it. A rack looks like this, a battery room over there. These are the things. And as that grew from that into ultimately what we later called data centers, or first, data room, server room, data center, all its legacy was in that telecom stuff. All the early operators were telecom people. With some real estate people that came along to handle the generators or whatever. So you had these big companies that could really influence. They decided the standard. It was whatever, but there's just one or two of them. It wasn't a consortium of companies.
No.
Now the landscape today is different in that you've got 6 AT&Ts or 8 AT&Ts. I'm wondering what it is for the common good.
Well, the hyperscalers are now
for sure.
Are now that. They're the people who are driving... Number one, they're driving the need the hardest. They have the technical capability to understand what needs to be changed. We employ, people from the data center industry, but understanding the compute need, and we, are starting to work in a much more collaborative manner. OCP is exactly that. The basis of that idea, which is not everything can be very radically different. And electrical code, ASHRAE, that all helps set standards around building infrastructure. But I just don't think, we all are taking into account just how quickly the likes of NVIDIA are driving the market forward. It's a very different pace of change than we've ever had to deal with in the past. And it's not going to get any slower.
I want to dive into collaboration in a second, but before I do that, one of the things that you reminded me of, I made a note here, is I work around a lot of hardware people, hardware infrastructure, tilt-up walls, whatever, all this infrastructure that we're talking about. And so in the conversation about changing something, we can imagine the physical effort to go in and, how do I keep operations running while I go in and make a physical change? All the safety around that, all of the planning, the backout plan, all of this other stuff. People who do not, I'm sorry, go ahead.
No, I think
well, here's where I was going to go. When you're a software company, you're not a software necessarily. You've got a lot of experience around it. But in their world, many times it's a matter of patching. It's not that the effort isn't as hard. It's a different kind of effort. How do you have that translation between, look, you can't just patch this. I know there's risking to patching. All of these other things we solved from the cloud fire or whatever it was that happened this summer. So patches can go awry for sure, but the level of physical preparedness to go in, make a change, remove something, insert a new thing, there's a go, no-go line here.
There is.
How do you have that conversation?
So as a hyperscaler, at this, given the size of what we're deploying, the hardest thing as a colo provider is when you've got a multi-tenant, and worse if they're hanging off the same infrastructure. So you've got multiple customers all on the same UPSs, on the same header for your cooling. Then the coordination of finding any day of the year where they'll allow an outage, it doesn't happen. That's why we design so much resiliency into our system, so that if we absolutely have to, in extremis, we run on one cord instead of two, whilst we upgrade one half, and then we do the flip and we do the other half. I think the nature of what we're seeing for AI might change that, and we might get that sort of tiered data center architecture that Gartner was harping on about for many years, 20 years ago, where you design different parts of the buildings to different levels of resiliency, because in the AI engines themselves there are checkpoints, and do you care if you have to roll back 10 minutes?
Right.
And so there is a sort of a reimagining of what does resiliency look like, what does maintenance look like, what does the building need to be when it starts, and what will it need to be when it ends, and how much time will you have to enact those changes? Because we can't, in our industry, we can't go out and hand over a building and then 3 weeks later do service pack 1.
Right.
Yeah. It just doesn't happen.
Right.
Yeah. But we can plan for the fact that, hey, we're going to start like this, but then we're going to add more capacity. We're going to make sure that the piping is oversized, so that at some point in the future, when we need to add those additional chillers, well, the piping doesn't have to be written. That's going to be we got very good at being very cost efficient, and so you scrutinized everything, and your QSs were going, well, that piping's far too large. We don't need that. We should do smaller. And then you will find that you'll paint yourself into a corner. So for the stuff which, it's not free, but it's not expensive in the grand scheme of things, make sure that you've planned for the end state, because then, if you've put in the pipe work to be able to cope with 12 chillers instead of, the initial 8 you think you're going to need, well, guess what? That's going to save you a hell of a lot of pain and suffering later. So plan for what you can, give yourself plenty of upside, and, and be open and transparent with your developers about, this. Yes, I realize we're starting here, but in 5 years' time, I might need this. How can we give ourselves the maximum upside without breaking the bank?
And have a conversation with the chip maker that says, look, whatever I deploy, even if I multiply it by a factor of 5, this is the physical. Nobody likes to strain capital. Right.
No.
So I don't want to build a shell or infrastructure for a factor of 5 when I only end up needing a factor of 2, or just as bad, I actually need a factor of 10. So how do you have a conversation with an organization, your internal conversation or whatever, that says, look, if we project out the next 3 generations of the GPUs that we're going to be using, this facility, it's almost like a nuclear power plant. We can get you this much power for this long. Then we have to shut it down, clean the fuel, replenish the fuel rods, do all this other stuff. And it's going to be offline for a period of time. It's not dead, but it's offline until we get it all restored. And then it comes back online, and the next in sequence comes off of line. And that, when I'm around software-minded people, they don't always think about it like that. When I'm around hardware people, because they're imagining dirt moving, piping coming out, piping going in, it's a different order of magnitude. Is that the same in your world, or not so much?
No, it's the same. But I would say this, which is, you can make it so you never sleep. trying to work out what's the optimum data
Sure.
center. Yeah. So you can literally lie awake at night and just kill yourself over the stress
What a
of
horrible way to die.
stress of working this out. Or you got to sort of like compartmentalize some of this stuff. The things that don't change when you've got your data center or you're developing it is you buy a plot of land. That's not changing. You bought the plot of land. You don't get to develop outside of it. You might, if you're lucky, be able to get the next parcel.
Right.
But in general, that's a constraining factor. So the amount of land you've got is a constraint. The amount of power you can get on that land is a constraint. With the world may change dramatically, and we might all be onto our own, on-site nuclear fusion reactors, super clean energy.
Talk to me after this. I just interviewed those people. I'll tell you when that could happen.
Right. Okay. So we'll talk about that later. But effectively, then your overall envelope for the building is set by the amount of land you've got. The overall amount of power you can deliver, irrespective of what goes into the data center, is set by the amount of power you can get there through the substation or the utility or your on-site generation. It all takes up land, so that's the trade-off. And so I think the key then is if you're constrained by the amount of land, you could make the data center space a meter by a meter and have everything else just be power and cooling and put the most performant, highest density 1 gigawatt compute cabinet in a single space, and everything else is just infrastructure to support it. But you better land that deal, and that technology better get delivered if that's your design.
Right.
So I think the key at the moment is don't design too densely. Remember, there's this 20 kilowatts down at the bottom end. There's this 130, 200, 300, 1 megawatt on the other end. Work on the principle that you are gonna strand some capital in the cost of the shell. The key is not to strand the capital in the cost of the power and the cooling. We used to think, you and I, about the number of sellable cabinets. It was about maximizing the white space.
That's right.
That's the opposite paradigm now. It's maximizing the utilization of the power. The power is what you're selling. The power and the cooling is what you're selling. And the space, the white space that it fits in, from our side of the fence is a freebie. You give that to us. That's just so we can consume your power and cooling. And so if I end up with one of my facilities having 4 computers in the middle of a data hall and a roller derby ring around the outside, I don't care. Because as long as that compute is delivering the compute capacity I originally expected out of the 20 megawatts I've just contracted, everyone's happy. I don't care that there's white space that's left over. Yeah. And so it's just understanding, don't design too densely, give yourself that trade-off of the sweet spot. And if that means that you're having to set certain proportions of the data center fallow because you can't power and cool it, that's a great problem. You'll deal with that later if you get additional power coming in from the utility, or you find a way to get more efficient cooling into the space. But don't go there now trying to intercept a future position and then find that, oh my God, I'm too dense, and with all the pipe work required, I just can't utilize all the power and cooling, because that would be the death knell.
Right. It so reminds me of a conversation about 10 years ago. I cannot remember which hyperscaler it was now, but I would guess, but I'll just get it wrong. But they said something like, look, this was in the era where cabinets were 3.5 kW a cabinet.
Yeah.
They said, what I want you to do is design me a 10 kW cabinet. I know others. This is really normalized liquid cooling. Everybody said they could do it, but there was no normal liquid cooling deployment. The conversation was around containment, right? Either hot aisle, cold aisle, whatever your flavor was, but it was around containment. And they said, look, here's what I want you to do. We're standardizing on a 10 kW per rack design. Now, what you think I'm saying is 3.5 kW. No. I'm going to utilize every single watt out of that 10.
Yeah.
Probably at 90% utilization, not 80%. So write your SLAs and whatever to that effect. But that's what I'm going to do. But the reason why I'm capping it at 10 kW is so that I have the most opportunity for your competitors. So in other words, I can come to my company. This customer said I can go to a dozen companies, and they don't really have to do anything exotic. There might be a little bit of containment they may need because it might be an older data center.
Yeah.
but they don't have to do anything exotic. And now I've got the most flexibility. And so now what you're describing is a different level of exotic and parameter, but a similar mindset, which is to say, to design for perpetual change is a very difficult thing to do. And if you can figure out what that design is, you need to go build wormholes.
Yeah.
Don't do data center.
The output of the future could be a single breaker out of a UPS at 1.2 megawatts.
Right.
Yeah, I can see that. Why bother, with the distribution if what you need is just that feed to the cabinet and that's it?
Right.
I mean, we could go down another rabbit hole around, what does the distribution of the future look like? Is it, and is now DC's sort of time in the sun?
Right.
I mean, everyone.
There's a lot of talk about
There's
it.
a lot of talk about it, and and candidly, I feel that it has much of it has merit.
Right.
But at the end of the day, if you want to keep your data center relevant, if your data hall is 6 megawatts, keep it 6 megawatts. Mm-hmm. And understand that the next generation, you're going to upgrade the electrical infrastructure. You're probably going to have to do something around the cooling just to basically concentrate it. But that data hall, if it was 6 megawatts, it's still 6 megawatts. It's just filling up a lot less space. Mm-hmm. Because otherwise, if you look at the space and go, okay, I got 300 cabinets in there before. I need to get 300 cabinets in there again, but now they're 10 times the cooling and power need. Your brain will break.
Right.
Trying to work out how to do that modification and do it in a timescale that isn't basically blow up the building and start again.
I'm going to pivot, or we stay on this conversation the whole time. You Brits supposedly have some good writers in your history.
I've heard a few, yeah.
Yeah. Mr. Shakespeare tries to make a claim to that. But we in America, we have this guy named Tom Clancy. Have you ever heard of Tom Clancy?
I do know Tom Clancy, yes.
And one of the things I loved about Tom Clancy novels, where is this going, McCall, is that almost always the leader of one government had a red phone to talk to a leader, not necessarily president to premier.
No,
or
generally in the
president,
background.
But
head of KGB to head of CIA.
Something like that, right? Like I could.
Yeah.
So in our world, I'm doing this terribly, but in our world, when we're talking about collaboration, I don't know that we would get the senior most leader at Google or Oracle or Microsoft or whatever to talk to the other one, or even that they would care. Yeah. But how do you think there's a need, or is there does there exist this sort of back channel opportunity to talk to your peer at some of these other folks? I'll bet you some of you have worked together.
Well, that's the joy of our industry, really, is that it's a massive industry, but from an employment perspective, we're not huge.
Right.
Not in the data center field. Oracle's an enormous company, but so much of that is software development. My area, it's 50 people, it's 100 people, and we know each other. Yeah, and we've probably worked together. Yeah. And if we haven't, we know someone who has.
Yeah.
So
2 degrees or so for separation.
Yeah, I think if the norm is 7 degrees of separation, the data center industry is probably 2 or 3.
Right.
Yeah, you'll definitely be able to get to almost everyone in the field.
If you're 40 or over, it's no more than 2. If you're under 40, it's at most 3.
Yeah, absolutely. And so we definitely have those conversations because we're all, dealing with, again, back to that point we made earlier on, which is we're dealing with problems that the industry has never faced before. They're good problems. They're things that need to be solved. But the idea of loads which dramatically oscillate, the fact that, we have to get liquid cooling into the data hall, the fact that, hang on a second, this is a how many megawatt cabinet? Why struggle to try and solve all of that yourself? Mess around getting patents on it and have the industry suffer. The credibility of our entire industry suffer because we didn't get to the answer quickly enough because we didn't pool our resources and work it out. And fine, we can go, once we've got the basics of the delivery of the facility up and running, we'll go off and compete around the quality of the offerings inside the facility. But on the basic stuff, there's a reason why apart from the US, the standard voltage is 415 for data center delivery.
Shots fired.
And there's a reason that there's a reason we have the standards. We need electrical safety. We need to be able to know that if I'm producing a device in Taiwan, I can take it to Europe, Japan, South America, North America, and I can plug it in and it will work. And so this is I don't see this as much different. This is us collaborating to work out how do we deliver what the world needs, what our end customer needs, which is the most performant compute it can purchase, to do incredible learning, to be able to then deliver services that you and I are only just sort of starting to imagine. And if we slow that down because we can't get our act together about what does the cooling loop look like, what does the building telemetry need to be so that we can deliver that, what's the power of topology? Case in point, GB200 is 8 power whips, 6 of which must operate. So that's very simple. Once you've got your head around the fact that changes our normal A and B power feeds to A, B, C, D. Recently, someone came along and we've got this alternative. It's 5 power supplies. So, now I have a problem because now 5 is a silly primary number and really stupid if you're trying to then deploy that into a data center you've already designed with 8 power feeds. So can you make it 4, please? Can you make it 2? Can you make it 6 if you absolutely have to?
Just divisible.
But just make it divisible by what the infrastructure I'm already putting in. And that's the thing whereby unchecked, someone will go, well, that's perfectly fine for me. And you end up with this 5 power whip monster that doesn't fit in any data center that's been designed prior to that for GB200. So we collaborate and say that's not going to work. You need to go back and re-engineer this so that it will fit in the data centers that we have designed. Because yes, we're going to have to innovate at the pace of the IT in the future, but that doesn't mean fundamentally changing things around the number of feeds to the row, to the rack, to the sizing of those feeds, if we can at all, not have to deal with that. And so not allowing companies to go, we think 7's a good number for the number of power supplies. Well, guess what? It's another primary number, and we should line you up and you'll shoot you.
Always lose your chips on 7. So I understand the back channel stuff. That makes sense to me. One of the reasons why I wanted you to come on the show and have this conversation with me is and I don't mean this as a shameless plug for our company, but you remind me of somebody in my company named Travis Wright. Travis is in my utility group. And back when it's 10 years now, it's got to be, maybe not quite 10 years, 7 or 8 years ago, he went to our board and said, I want to move out of running a data center. He ran one of our Dallas data centers. Energy has always been near and dear to my heart. And I want us to help frame out our ESG, our how we buy power, and just get sophisticated around this. What should we do? How should we do it? And then I need you to trust me on this. As I get sophisticated on how to source power, how to teach my team on how to do that, how conversations with power brokers, et cetera. It is not a normal thing for data center people.
No.
We know how to build data centers. We don't necessarily know anybody in that industry. I want to share it from the stage. And he would share the big idea, and then at small dinners, he would invite people who he had not worked with, but they came from other hyperscalers, they came from other data center operators, and they began building the back channel stuff, but he started off with this on-stage conversation. You are the only person, I'm not saying it hasn't happened, but I attend a lot of these events. You're the first person I heard who stood up and said, this is what we're designing, not the proprietary stuff, but this is the big idea around these GPUs, probably not dissimilar to what my competitors are doing. And this is what you know. What you don't know is this part is unknown to everybody like me. And if they're saying that it's not unknown. They're not truthful.
Yeah.
You said it in a much more colorful way that is not appropriate for a corporate podcast, but it was very funny. And I was so surprised by that. I love that attitude because it says, I'm confident that in my ability to perform in the marketplace, period, with what I am bringing to the marketplace. But two, I'm also confident that if we don't really collaborate, not just the lip service, that we're not going to solve this problem, and somebody else will, whether it's another nation state, it's another whatever it is.
So that's the biggest one.
And then let me just, this one other thing. What happens then is, so while you're speaking to your constituency of the people who should collaborate, to the industry at large, 20% of that room is going to be cynical and say he's full of crap. Either he's not being truthful or they really have figured it out. But some 60 to 80% of the rest of the people, whether they're cement people, whether they are fiber people, whatever it is, receptacle people, are going to bring that back to their leadership, some percent of them, if we keep saying that and say, look, we also in our world need to be able to have these kinds of conversations because it's all being disrupted.
Yeah.
And this is the consequence, either in the micro, that company over there, that 3 or 4 group that figure out how to collaborate are going to defeat this larger company, or on the macro, this country who may not be as favorable to the world as we are going to excel at it.
Yep.
And the consequences then are much larger. And I don't want to be melodramatic, but just that having that attitude on stage, I think has far-reaching repercussions. And why do you have that mindset?
It's very different than when I was working, at the colo side of the house, and when I was working at Equinix. There is because now I'm not the product. The data center, as far as I'm concerned, is not what Oracle offers.
Right.
I'm an enabler for the real product, which is the compute and the software.
Right.
So what's the best way for me to enable that? It's to be open and transparent about all of the issues that I want this industry to help me solve, to be able to deliver my software and my product to my end customer most effectively. So I don't see it as a market differentiator that Oracle got it right and Microsoft got it wrong. I see that as an inhibitor to the adoption of all of the AI engines, whoever's using them. And candidly as well, I think, from my senior leadership, if I look at, Clay McGurk and I look at Safra and how they are enabling sort of the multi-cloud offering, there is a sort of maybe a different mindset inside Oracle, which is, that, hey, we've got good products and services, but you like the Azure interface, that's okay. We'll put this in the background and we'll do a collaboration with Microsoft so you get the best of both offerings. And we're doing that with many customers. And so, with many partners and many of, what you would consider to be our competitors. But I think it's just a maturity level about, we do some great things, but people use the front end from someone else's, offering, and that's okay. You can look back in our entire history, where it's proprietary. In general, it tends to lose out over time to the open source option, because you just paint people into a corner to the point where they start to resent the fact that, you mean the only place I can get the support from this is the manufacturer, but I don't want that anymore. I want something different, and they're slow and they don't innovate, and so that's when the new entrant comes along and the open source, tends to win. And I think, that open source in our industry is the free flow of ideas between companies. I think we might be the first people to have published our design specifications. Maybe not. I mean, I think
certainly one of the first.
One of the first, and every time we engage with a colo provider, we give it to you. We do it under NDA, but we give you the specification, because what do I want you to do with that? I want you to build me a data center that meets my need. And if I share that information with you, I don't have to sort of like, play a game of cards with you going, what do you think the pipework should be?
Right.
Do you think it's 12? Well, I think it should be bigger.
Is this a 4? Maybe.
Yeah. So I don't know. Maybe I'm just old now, and I don't have much time left to get my ideas across. So you better be able to take it all at once.
Right.
Yeah, because otherwise, we could play a dance, but I just don't see the point in that.
Yeah.
Yeah, there are much more important things to fix than whether, as I say, the pie is getting so much bigger. We don't all have to worry about whether we're going to get a slice of it.
I hear what you're saying. And perhaps there is some element about, having matured. Older is not a word I'm willing to embrace yet, but matured and whatever, and you're trying to get to the end game. I have worked around, as you have, plenty of people. I guarantee you this was true in the Air Force. This is true in telecom. It's true in data centers. There are plenty of people that want to be the cock of the walk.
Sure.
And there's an element or two where I will, be very competitive or whatever. But it's uncommon, at least publicly, to say to be the first one to do that sort of rallying horn, not in the back channels, but in the front channel. And I appreciate it. And I think that hopefully the repercussion isn't just in the immediacy of the data center design stuff that we're working on right now, even if it's just that you guys agree on something. Yeah. We agree that this is the framework and this is the thing, and that gives QTS and Aligned and Cyrus and Digital and Equinix or whoever the opportunity to go and do these things, right?
And again, it's about defining the interface. So, for instance, let's just sort of talk about the output from the building management systems. Number one is I don't want to be in your BMS because you don't want to, you won't let me, and I understand the implications of allowing third parties into the most important system in the data center. Right. So we know that's not going to happen. So let's not confuse ourselves by asking it. But what I want you to do is expose certain data so that I can ingest that data and do things with it on the compute side. Now, as long as you expose that data, you can be as innovative as you like on the inside in the capture of that data in unique and wonderfully thought through QTS ways of extracting it from the systems without spending billions of dollars on microsecond power quality meters. Yeah. I don't care how you do it, but I want this data and I want it at this. I want it at this periodicity, because that's what I need to run my systems most effectively.
Served up to in this API or this way,
and
whatever.
And the quid pro quo of that is if you can expose from your building that, hey, one of my chillers is having a problem and starting to sort of might just go offline, or I've just lost the UPS, and so. If I'm getting that data and I can respond to it, the systems that I can now deploy as well, I can, you need me to turn down my power consumption. I can do that.
Right.
And I want it to be more, there was very little interaction between the building and the compute in the past, unless you were the hyperscaler or unless you were, sort of a research community. But there's so many things that the compute can do to safeguard the operability of the data center and vice versa, if we just trust each other enough to expose the data to make that possible. Right. Worst cases are always like, middle of the summer, someone's having a, absolute, it's a beyond design parameter
Georgia
day.
Power, Dominion are having some issue
and there's some other issue,
and
it's the hottest day of the year.
Right.
Well, if you're laboring on the data center side of the house, we've got to just keep it all up. Just get the boys on the roof, spraying things down with hoses. Right. Do whatever you need to do, but don't tell the customers we're having an issue.
Right.
Or tell us.
Right.
And then guess what? We can turn the wick down on the compute.
Right.
And instead of having a major outage, which then takes days to bring everything back up. And when I say days, I mean to make sure the databases are all coherent again, and all the equipment's up and everything is working. Yeah. If we can, trust each other, go, hey, we're having an issue, and can you turn a third of your nodes off to just give us that saving grace until the sun goes down?
Right.
Sure. we can do that. But we've got to trust each other to expose the data, because it isn't going to happen. Again, that back channel is not going to work quick enough. Right?
Yeah.
Me talking to you and going, hey,
Right.
Dave, can you get the guys to sort of like do something? Or Craig, can you turn the compute down?
Yeah.
It's got to be the system. So it's got to be exposed in a way that's can respond very quickly. And is in a way that we understand the data and we know that it's actionable because we've defined the interface. And in the background, everything we're building at the moment should help make this even better, because the AI inferencing we get from the learning engines around data center automation and management should make this something that the computers can just do themselves, and we can just drink cocktails.
Right. And I want the computers. I love all of that. But I want the computer then to say, hey, you're feeding me this information, but if you adjusted to this, this is unnecessary. But these other 8 things, it would allow me in real time to respond so much quicker. I don't know if you know this, but in 2009 at QTS, I was a solution engineer for them, and our Swanee data center, which had never gone down, we had, as we grew, we started off with I don't remember what it was, maybe 8 megawatt, 10 megawatt high-tech flywheel UPS. Yeah. That was what was there before we became QTS. Then we added a 10 megawatt active power, and then we added a, 15 or 20 megawatt Liebherr, Emerson, whatever, standard battery
Static
UPS.
Static
UPS, thank you. But anyway, one of the high-tech infrastructure dropped the entire load. Everything failed. And as you know, data centers, if you can't stay up, if you're not 100% up, you're not a data center, right?
Yeah.
You're just a shed. And so we dropped the whole load. It was a catastrophe. The sort of mini catastrophe within that was when it came back up, because there was no explanation for it. It just dropped the load. And when that happened, we ran through our EOPs, we double checked all the SOPs, MOPs, we kind of started working the problem. We guessed at what the solution was with the manufacturer, high tech, and I think it was Square D was the installer or whatever. And this is pre-QTS, this infrastructure we had inherited. Not as a disclaimer, but it was, and we went through it, all the paperwork seemed to check out. 6 weeks later, did it again. Exact same system, did a load. This time, thank goodness, we were able to interrupt the EOP. We had made enough changes to the EOP, emergency operating procedures, that we were able to save a bunch of infrastructure and do non-destructive testing. Mm-hmm. And here's essentially what we did. We said to both the installer and the manufacturer, who were resistant to let us see the code and what had happened, whatever money we have remaining, we will sue you because we're going to be out of business. And what we learned right that second, our then CTO, Brian, said, and John, our next CTO, and Brent, our current CTO, all the same thing. You have to be spectacularly transparent. We got you know what the balance is between that storage infrastructure, that network, and that compute. Yeah. And we 2 times in a row, imagine you just restored your databases. Your customers are worried about you and what knuckleheads. And we were not the behemoth that we are now. We were a $20 million, $40 million company. I don't know what we were. We were 3.5 years in operation. So all of that happened, and it was every day in our call center, led by our head of operations and our CTO, with all your peers, you, that group, in colorful war room language you might imagine, but we were 100% transparent. Yep. We got everybody on board. They helped us rewrite our SOPs, our MOPs, our EOPs. They helped us shift loads or whatever. Thank goodness that's never happened again. Now, we've had cardboard failure. Components fail. That's why you build in resiliency and redundancy. Acts of God happen. But that was as it turned out, it was logic. It was a never imagined before string of things in the logic came through, and it didn't make before break. It was a frequency lockup, so the transfer switch didn't happen, dropped the whole load. But by the time it happens so quickly that by the time you check it, everything looks normal. So we discovered it. But anyway, we went through that, and I just so appreciated that my CEO was on board, my then president on board, my CTO on board. It's still our philosophy today. I'm sure not perfectly, but it was, we have to be spectacularly transparent or we cannot remain in this business because stuff is going to happen.
So I think that's the key there, which is stuff will happen. Like, anyone that's never had a major outage has been very, very lucky, because they will happen. It's not the fact that you had the outage, it's how you deal with it afterwards. How quickly can you get it resolved? And how transparent are you with your end customers about what truly happened? Right. And so we have our business reviews with you guys and all of our other partners. And I value very, very highly, as does my peer Jim Hawkins on the ops side, transparency. Mm-hmm. Because number one is, if you tell us exactly what's happened, well, guess what? You tell us about one location, but we've got 210 locations now. Mm-hmm. So I want to be applying that learning to my other locations. Right. And I'm not going to divulge, specific QTS information, but I am going to say, hey, we've had this issue in this data center with this equipment. You use that equipment. Can you please check these things?
Sure.
Because, again, what's my job? My job is primarily delivery and design of data centers, but the real job is delivery of services to my end customers.
Right.
And so if my learning from you means that I can prevent the same thing happening in 10 other locations, I'm doing my job.
Right.
I can't do that if you don't share the information.
And not just with you, but with the manufacturer. I might be getting Schneider on the phone or Vertiv on the phone, and I expect it to be a two-way street. I expect them to come to me and say, we have something at risk.
I think over the past 20 years, we have got far better at this. Yeah. We're a much more established, sort of industry, full stop. But we've also got beyond the trying to micromanage the things you truly can't manage, like identification of the location of your data center. I can't tell you that's a secret. Yeah, well, it's on Google Maps, so why are you making my life hard for no bloody reason?
I used to laugh at the people who said they write it into their contracts, we couldn't say their name, and all their employees would show up with the name on their shirts and mohawks and scooter, and they would cater the food in and
so
whatever.
So concentrate on the stuff that I can't remember. I'm certainly not religious, but it's certainly that give me the what was it? Give me the
wisdom.
The wisdom to know what I can change and the
wisdom to know what I can't. Give me the intelligence to know what I can change and what I can't, and the wisdom to know the difference.
Exactly. Yeah, and it's that. It's like concentrate on the things that we should be collaborating on. There's still plenty of peripheral stuff we can compete on.
Right.
No issues around that. But at the end of the day, what do we want? We want credibility for our industry, and we want to, when we retire, we want to look back and go, we built that, and we did it in a way that benefited humanity, not just the shareholders of my one company.
Yeah, that's right.
Because otherwise, what are we doing this for?
Yeah,
yeah, and humans are gregarious, collaborative beings. Right. We make the most out of what we can deliver through that collaboration. Right. MBA 101, teams make better decisions than individuals, despite what some of those individuals might tell you.
Yeah.
But teams make better decisions. Well, guess what? Multidisciplinary, multi-company teams make even better decisions because they share the complexity and can get to the bottom. I love what I do now for Oracle because I get to see under the hood of all of my colo providers and they talk with me. Mm-hmm. That's one of the advantages of being a hyperscaler. Mm-hmm. Whereas, we would be a lot more guarded if I was Equinix and you were QTS.
Yeah.
So.
Probably. You do have the British accent, and that seems to lower all. I don't know. It's a superpower. It's not a superpower in England.
It's not. But,
you're stuck on this little island, and as soon as you get off, even for people in South Africa,
it works the opposite way around when you go to the UK. You see, because everyone defers to the American as being, well, he's from Silicon Valley. He must know what he's talking about.
I have not found that to be true. I have found them. Sure talks a lot. He sure is earnest. Somebody I heard these two British guys, they made me laugh, and they said they were doing their own podcast, and they said one of the things that they were talking about things that they appreciated most about America versus the UK. And just for the record, they loved where they're from. They love all their friends. They're just saying, here's the thing that they appreciate in America. In America, if they had known a group of people, close friends, for 3 to 5 years, and they were going with that friend to a party and they were getting introduced. So if I'd known you for a while and I took you to my friend group and introduced you, I'd say, this is Craig Pennington. He's an audiophile. He's got an appreciation for the arts. This is his background. And I heard him on stage say these 3 things. And my friends would be like, wow, we want to know more. Yeah. You said, now, just imagine you're getting introduced to your best mates back in the UK. This is Craig. I saw him barfing an hour ago. Yeah. They would, and especially from Manchester, which I think these guys, at least one of them are from. They're like, they're not criticizing them. They're just saying, this is what I appreciate. And I told this to my friends from Manchester. They laughed and said, I don't know if it's good or bad, but it's certainly true.
It is different. The sarcasm it cuts in a lot quicker for the British. Yeah. We get very sarcastic very quickly, but we like the humor of it. So.
Well, they said that the Brits in general, and I find this to be true, and the everyday are funnier than everyday Americans. The difference is Americans, he said, now go look at how many stand-up comics there are from England. Sure. Not very many. They're world class. Yeah. There's just a few of them, though, compared to America and many other places. Yeah. And they said, why is that? Because the funniest guy funnier than most of these comics, is sitting next to you at the bar. Could you imagine, or at the pub, could you imagine him, though, saying, right, going to get a mic, going to go stand up there and start telling me, they'd be like, sit your butt back down, have another pint. They'd never let him. Like, it's not going to happen. So just differences.
It is. I understand that my accent opens doors and gives me more airtime than perhaps it should. Yeah. But, I'm going to use it.
Yeah, so. Why not? Why not? Well, look, we've talked a lot about a wide range of topics today. Can we end with this? One, if there's anything else you want to add that we haven't touched on, let's do it. But I'm curious. So you have, to your point, an exposure not only for Oracle in the middle of this most disruptive of disruptions in our industry. You also get you talk to a lot of providers, not just us. Yep. So what do you think we're going to be looking at in 3 to 5 years? Are we talking about the same things? Has microgrid and self-generation really become a thing? Is that not really a thing? Once we realize the regulation and all the components necessary, is it we really are ramping as hard as we can to 200 kW, whatever it is? And what do you think the milestones to say we're navigating a particular way or we're slowing down? Just one or two, maybe. What do you think?
Well, so the one thing that's going to be all pervasive and problematic for at least the next decade is just availability of power. And especially, for the US, just the rate of growth and the lack of, you don't have a full countrywide grid. Mm-hmm. So the access to power is, I can see that for our industry to continue to grow, on-site power generation is going to be necessary just because of the difficulty in for the utilities to create more power or to get it to where it's needed. Because we choose to go locations, at the drop of a hat and then expect that there's gigawatts of power. Right. And that isn't true. It can't be true. Yeah. Right. So, the issues in Ashburn there's no shortage of generation. Right. You just can't get it where you need it. Right. So if your entire growth model requires power, so it does, well, we're going to have to take more control over that, I think, to be able to deal with the growth needs that we will have. Mm-hmm. But energy density is a problem. So we can start, I'll put it this way as well. you mentioned at the start of the conversation about sustainability being a big deal, and not just predominantly our type 2 emissions from electrical consumption, but either type 1 from direct construction of data centers, certainly part of that, and then type 3 from all of our supply chain. But so we were all moving in the same direction from we must have access to clean, carbon neutral power. And I would say that what's happened over the past 2 years has actually put a bit of a hole in that, because actually at the moment we need power. And candidly, whether it's clean or not is a secondary consideration, because you can fight about whether it was clean after you've delivered the services.
Right.
And so it's all points in the direction, which is we will need SMRs, undoubtedly. I cannot see a future where we can do it without nuclear power, which is clean, carbon neutral, and we have some degree of control about where it's positioned so that we can build our data centers appropriately. And so SMRs, we've got to support the industry to deliver them. We've got to lobby to make sure that regulations around this are minimal. We've got to lobby the general populace and educate them so that they don't end up with too much NIMBYism, because that will hurt us. Yeah? And I just don't see how any country, but the US very specifically, can continue to grow at the pace it needs to without sort of an understanding that nuclear power is just going to be part and parcel of the need.
I just recently got to interview for the second time the folks from the GAIN program at Idaho National Lab.
Yeah.
And I asked them a similar question, and Chris, their manager of innovation over there, said, do you know how many actual SMR designs are approved? Some version of them are approved by the U.S. regulatory. I was like, no. A dozen? He said 2.
2, yeah.
And he said, so a milestone will be not the marketing hype, and he's not against the marketing hype of the micro or the SMR, whatever, but that they actually, the government moves to accept.
Yes.
And the designers actually move to, this is the design, however it's vetted out, wherever it's vetted out. And that's the design. Even if it's not he didn't say this, but I'm thinking to myself, I don't mean imperfect as in unsafe, the safest power in the world. And if you go with an honest eye or without, what am I trying to say, being disingenuous, and just evaluate in any way you choose to evaluate safety of energy, it's as safe as there is.
Yes.
So, and I'm not an expert in this area, so I'm not going to belabor the point, but other experts have talked about this. But when they talk about, they also say transmission is far and away.
It's where the failures are.
It's where it's harder for all these reasons.
Yep.
And so they like the big idea of going to deprovision coal sites or future because the transmission's already there, the infrastructure's there, you support these communities that have built this out in the U.S. But the milestone, the canary in the tunnel, is looking to see how many designs. Look, France, whether they've got the perfect design or not, they are able to move forward because they've standardized on accepted designs. China, others are doing this.
There's some amazing innovation on the systems, but you've got to get it through the regulator, and you've got to just choose a design and move forward. I think the light water design is sort of like, it's well understood. There's a whole raft of submariners who know what they're doing around it. You don't need to innovate beyond the capabilities of the people that are going to need to deliver this. Right. So just, it may not be the best, but it's more than good enough. Right. And you can argue, there are other opportunities for people to innovate, but candidly, look at the regulator. If you're going to have a small government, which over the next 4 years is likely to be the case, is the regulator going to want to manage a dozen designs and and then sign off on them being safe? Right. Or are they going to want to manage 1 or 2? Right. They're going to want to manage 1 or 2.
1 or 2, turn the marketplace loose on it. Yeah. And
innovate around this, but this is the core technology. And don't expect we're going to sign off on anything else.
Last question, the ridiculous question. Do you imagine, do you think there will rise a chip? Here's what seems to me so interesting. There is a player, NVIDIA. I've got to go to NVIDIA. I've got to meet Jensen.
Yep.
What a personality.
Yep.
It's charming. The people that work there are super smart.
Yep.
Like in every way, I enjoy it. That's not my business. I love to partner with them. I love to, it's amazing, honestly. But nature abhors that one provider. Sure. I'm wondering whether it's AMD or Intel or people not known yet, how they're going to rise to that. And the second thing is, how do we sustain to your point in the very beginning of our conversation, every 18 to 24 months, a new possibility, much less the data center to support it, the manufacturing supply lines to run it, all this other stuff. Once we standardize on a design, we want to get, we know the truth of data centers. A tier 2 data center that is so thoroughly vetted, has a spectacular maintenance program or whatever, is much more resilient than a tier 3 that is newer, that hasn't gone through the shakedown, that doesn't have a strong preventative maintenance. And so while I might have less resiliency on this tier 2, it's baked in and I'm managing it perfectly.
Yeah.
So whether there's an abundant amount of power available or not to supply these chips, do you imagine it will slow down, not the design, but the adoption of it at scale? Or do you think it's just going to be every 2 years we're going to have a new cycle deployed?
Every 2 years we're going to get a new cycle deployed, and the new entrants to the market will keep that pace. Because we had that with Intel and AMD in the CPU space for forever. So, everyone wanted the most performant chip.
But they weren't orders of magnitude.
No, agreed. And so the key here, though, is just like we just spoke about the nuclear power, set some parameters, which is innovate within these parameters, because if you go beyond them, you're starting to make it really hard for me to deliver all of the things you need me to deliver. Classic case in point has been the spiky waveform, and when we first started to see that and how we were going to deal with smoothing that to make sure it wasn't going to become a problem for all of the infrastructure and the utility. Yeah, so now that that's well understood, that hey, we need to actually manage this within what the utility can provide from a frequency response, from a slew rate perspective. So we've started to put some boundaries on some of this innovation, and it's not going to kill the innovation. Things are still going to get much more performant, much smaller form factor, much closer together, faster switches, and that cabinet is going to keep on, going up in power. But we're not going to ask it to do things which are unnatural, which is like we want it to be a megawatt single cabinet, 57U high, and it's got to be air cooled. There's none of that. We know what the answers are now, so we're going to be able to deliver against that. And it means that I do see, my white space is Gen 1 will have 20 cabs in it.
Right.
And Gen 2 will have 10 cabs in it. And Gen 3 will have 4 cabs in it. And then maybe there'll just be one in the middle of the room. But I think that's manageable, providing the upstream infrastructure, we can make educated decisions now about what the future needs to be without it being overly complex.
Yeah.
Now, the realization that some of the things we're currently grappling with, the real groundbreaking stuff, such as this very spiky waveform load profile of the compute, it's well understood. And you're right about the guys at NVIDIA are smart. They've hired some excellent people. They understand some of the issues they're bringing to the space, and they're partnering with us and everyone else to try and fix it, so that the next generation, it's not as hard for us to adopt it. Yeah. And so again, that comes back to my be open and transparent and tell people where the problems are, and don't beaver away thinking you can fix it in a vacuum, because you're going to get far more support and far more done if you go, excuse me, this thing that you're asking us to put into the data center, it's going to break it.
Right.
Why? How will that happen? Well, these reasons. Oh, okay. What can you do to fix it? Well, we can do these things. Okay, we'll go away and do what we can on our end. Yes. Right. And so, they've got software rate limiting for, the amount of power consumed by the chips. Now, you don't want to use it if you can at all manage it, but at least it will see us through until the big fixes come.
Right.
And, and the other thing that will help us understand this better and do the next round better is obviously getting, the first round up and running. And so we can see, instead of just looking at the simulations and thinking we've got it right, we'll have real world data and know whether we've got it right.
Yeah. Well, I cannot wait to see what it looks like, what we got right, what we crack up about and say, we didn't see that coming.
Sure.
And what I love about, and I would agree with NVIDIA for sure, is as long as they maintain their culture, as wonderful as the designs are, we loved NVIDIA back in the days when I was a gamer, video gamer.
Yeah.
Their responsiveness, they unseated, they weren't 3DFX or some of these other early card manufacturers, but they were, from a gamer's perspective, the most responsive, constantly iterating. And they also, by the way, to your point of open source, would let you overclock way before anybody else would. They would let you overclock. They would let you mess around within certain parameters.
It all comes back to the transparency issue we're discussing. Be open and transparent about, hey, this is what we can do. This is what we can't do. These are the things we're grappling with. These are the things we think we've got solved. We're not going to go look at that because it's hard and we've got other things that are more important. Set the parameters so that everyone understands where you are, and that should be just, we're a technical industry. We're all very highly educated, very professional. Treat people like adults. Give them all the good stuff and all the bad stuff. And guess what? If you give them the information, they'll help you make good decisions.
Yeah.
If you treat them as children and compartmentalize the availability of the information, you don't get as good an answer.
Yeah. Well, Craig, thank you for saving your life at the top of those stairs. And thank you for joining me today.
Pleasure.
Hey, if you liked that conversation, hit the like button. If you loved it, hit the subscribe. We'll see you next time, everybody. Have a good one.